fundamental concept of dimensions that looked much more like a fractal structure. Although I didn't know fractals at the time, I solved the problem of dimensions by saying the exact contrary than the standard axiom, by saying that the only thing that exists is the dot. The only thing that exists is the point. That dimension 0 is divisible to infinity, and that the universe makes dots of all sorts of sizes that are divisible to infinity and arranges them together to produce all of our material world, of all of our reality.
Is the opposite also true? You were removing yourself from the bus, from planet Earth, from the galaxy. Is the opposite also true if you were going backwards?
If you're going back, explain what you mean by that.
Instead of you removing yourself from the bus and from planet Earth, can you actually do that backwards and go in? In other words, looking into the most minuscule atom and continue going there infinitely.
Yeah, that's what I was doing in my hand, right? I noticed I was made out of cell, and the cells were made out of atoms and so on. And so
right.
You can divide to infinity towards the center of a system, or you can expand to infinity. You know, when you talk to children and you say, okay, well, this is our universe, it has these type of boundaries and so on, the first thing they ask you, what's that universe in? You know? And I think it's a fair assumption to think that our universe is most likely embedded in a larger one, which is most likely embedded in a larger one, and so on to infinity. So it starts to look like a continuum of infinity, infinite boundaries embedded within each other. And that gives you a worldview that's completely different, that's completely modified from the typical Cartesian plane and Euclidean axioms.
Nassim, for our listener audience, please define what the unified theory is and how it can help us in our understanding of who we are today.
The unified field theory in physics is thought to be a theory that would unify the four forces. The forces that rules the large world, that would be gravity and the electromagnetic field, and the forces that rules the small world, the quantum world, the world of the atom, which is a strong force and the weak force. Now, these two theories that describe these forces, in one case, Einsteins Field Equations, relativistic theory that describes the large world, planets, suns, galaxies, and so on, don't agree with the quantum world, which predicts the atomic structure, the electrons, the subatomic particles that are made of, and so on. The two predicts two different things. The relativistic equations predicts that things have a continuum kind of function where it seems to go towards infinity, towards singularity. And quantum theory predicts that it's not infinity, that it's boundary conditions that are very defined and that are linear in functions. And so one says it's infinities, the other says, no, it's boundaries. And what I found from the exploration I did is that it's always both. And that is what unified the field for the physics I wrote. I realized that, in fact, you can't get infinities without boundaries, and you can't get boundaries without infinities.
Every person, and I heard this at another interview, every person, whether it's Copernicus, Galileo, Einstein, Planck, or any of the great minds in history, the one thing they have in common is that they made observations of what already is. They just translated it into mathematics so that other physicists could use it. Do you believe the answer to many of our questions is already here for us to discover?
Absolutely. I think that one thing that has been the major issue in current physics is that we have kind of gone away from an experience of nature, observation of nature, and then extrapolating theories from it. Instead, in general, our physics are explored by, writing further and further complex math and trying to find unification principles by adding many, many dimensions and so on, and actually complexifying the theory. And I think that actually what's crucial is for us to return to observation of nature, because I think that in nature is all the answers. We just got to look at it with a critical eye and experience it, and from that experience we can, we can extrapolate very fundamental principles of creation. Many of the giants of science did exactly that. They experienced nature, they observed it very critically, and they extrapolated advanced theories from it. And that's kind of missing at this point.
Nassim, you frequently talk about the geometry of the universe. I also saw you mention how you climbed a mountain with your telescope to watch comet Shoemaker-Levy hit Jupiter. You also observed how Jupiter's red spot is 1.5 the size of Earth, and how it stays on the same spot that you'd expect that perhaps like a hurricane, it would deviate, it would dissipate eventually or move in a latitude different than the one where it is, but it does not. You said that it could be the tetrahedron inside the sphere. That spot is latitude 19.47 degrees. We always call it here at the show 19.5 just to round it. Not only you have noticed, but other researchers like Richard C. Hoagland. What can you tell us of the significance of latitude 19.5, not only exhibited on Jupiter, but Volcano Olympus Mons on Mars, the Mauna Loa volcano in Hawaii, the pyramids at Teotihuacan in Mexico, and many other locations? Can you tell us more about latitude 19.5 and its significance?
Yeah, I can, in order to make that clear, I would have to explain a little bit more about the theory I wrote. The theory I wrote, as I was saying earlier, as you know, I explored it further and further from my childhood, showed that actually finite structures and infinite continuum were related by geometry, related by the fundamental structure that would be fractal in nature. And people at home can even try this. Don't try it if you're driving right now, if you're listening to the show. But if you have a piece of paper and a pen, you can make a circle, and inside the circle make a triangle, an equilateral triangle, and then put a reverse triangle, and what you'll have is a 6-pointed star inside the circle.
Like the Star of David.
Yeah, like the Star of David. And actually, it's interesting that this geometric example, which is one of the most important one, I believe, to describe the relationship between infinities and finite system, that very example is found in many, many different ancient cultures all around the world. But if you take that Star of David or that 6-pointed star and you put smaller triangles on each of the points, you'll get smaller Stars of David. You get next resolution down of the fractal structure, and each of these new Stars of David are going to define a very specific space that you could put a circle around them and get a new boundary. And each of these boundaries is a very individual coordinate in space-time. That is, they're all very specific in their position to each other, but they're all part of the larger boundary you started with. Then you can make smaller triangle on that new set of tetrahedrons or that new set of triangles, and now you get even smaller boundaries. And you can continue to do that, get smaller and smaller and smaller and smaller boundaries. You can do this to infinity. If you give this to a computer,